Hi, welcome.
Hello.
Hi.
Hi.
That was a really tired sounding. Try it again. Hi, everyone.
Hi.
Ah, there we go. Now we're awake.
My mic crack.
So we are starting our work in geometry. But before we can get into the kind of real heart of geometry and all the arguments we're going to end up having throughout the year about what's a shape and why is it that shape, we need to step back a minute and clean up some of the algebra. You guys took a quick pre-assessment for me yesterday, and I saw for quite a number there was question marks, and then you gave it your best attempt. I haven't gone through and read all the details on everyone's attempt. I just skimmed them real quick to get a snapshot of what we're doing, and I know that there's still a lot of concerns. So we're going to double check the properties of real numbers, the things we can do with them, and it's a little crossword puzzle. Okay, so we'll go through over these. I'll give you all the different words so then you can fill in your crossword puzzle. Filling the crossword puzzle will be homework. And then we'll work on the algebraic expressions. This is what was on that assessment yesterday. And we'll do some solving. Okay. I am going to write in a bunch of different colors today. I'm going to write with the rainbow. So if you have rainbow colored stuff, you're welcome to very quietly pull that out and get that ready. And I'm going to give you guys a couple minutes to shuffle around and get that going for yourself. And I'll just kind of chat a little bit and fill time. I probably should have asked you to get these out before I started the recording. Derp. Got the door. So markers, crayons, highlighters. Try not to write with dry erase markers. Those the paper eats the ink on those really fast. Sharpies are fine. Maybe consider putting another sheet of paper under the Sharpie just so the Sharpie doesn't bleed through and onto the desk. Gentlemen working on the word searches, which is cool, but when we get started, just slide it off to the side, all right? Right on, my homies. All right, everyone who's going to get colors has colors.
Yes.
And studio audience at home following along later has their colors. All right, let's go ahead and do this. All right, here's the first property that we've got. Looks like we've got two numbers inside parentheses and then a number hanging out outside. And then that turns into the number hanging outside hanging out with the first number in the parentheses and the number outside hanging with the second number in parentheses. What is that?
Distributive.
Louder.
Distributive.
Yeah, it's a distributive property because we're distributing that A through both of those things in there. Okay, so let's make sure I spell this right. I'm really bad about spelling. Distributive. It's a capital R, not because it has to be a capital R, but because I think in this context the lowercase r would look confusing. And so my R's are going to bounce back and forth between capital and lowercase. I'm sorry. Just whatever my hand decides to do, that word is what it's going to do. Distributive. Very nice. A equals A. A thing equals itself. What do you think?
That's identity.
Property? Oh, what identity?
Identity.
Identity property. It's related. It's going to feel related.
Zero property.
Zero property, again, related, but we're not going to, we're going to save the zero and the identities for something else. All right, this one is, trying to remember, the reflexive property.
I knew that.
You knew that one.
No, I didn't.
You read it from my mind. You put it in my mind. The reflexive property. All right, I've got a thing on the left, and I can rewrite it, and I just swap the order. Oh, I love that word. Not the inverse property. I like that idea of swapping, though. It comes in an inverse. Hold on to that for algebra 2. I'm going to start writing it, and just shout it out when, here.
Substitute.
There it is. Symmetric. The symmetric property. The next one, we've got a thing, we're adding 0, and the same thing that we had comes out.
Zero property.
Ooh, because we've got a 0 in there. I like where you're going with it. It's not actually called the 0 property, but I like where you're going with that. Try again. Any other guesses? I've got some number which we're calling A, and then we're adding 0 to it, and we're getting that number out again. Okay, I'm going to start writing it. Shout it out when you think you know it, and I'm going to try to read
Numbers.
it. Identity, there it is. The identity property of addition. Multiplication also has an identity property. Can you tell me which line number you think the multiplication, the identity property of multiplication is?
9,
It is not 9.
10.
It is not 10. It is not 7.
12.
It's 12. Thing times some number gives you the thing you had to begin with. That is an identity. Good. Good. Did I leave my radio? All right. I have this group with addition. There's 3 things being added. And notice in the left side, I've got the first 2 things grouped together. And on the right-hand side, I have the last 2 things grouped together. What do you think that's called?
Commutative addition.
Commutativity. Okay, distributive because it's got the parentheses.
Mhm.
I like where you're going. We've already used distributive, and notice with distributive there's multiplication involved. And here, there's no multiplication, it's all addition. I can see, though, how they look very similar. Mhm. What was some of the other things that were said? Commutative. Commutative is when we're moving things around, so order isn't important. It's going to feel a lot like the symmetric. But this one is not commutative. I'm going to start writing it. When you guess it, please feel free to shout it out.
Associative.
There it is. See, you guys know this. You know them. Right? All right, I got a thing with multiplication, and it's multiplying the thing by 0, and out comes a 0. What do you think this is?
0.
Yeah, this is the 0 property. Right on, man.
You're so smart.
You are. Number 10 looks really similar to one we've already done. Doesn't-
4.
Yeah, it looks like number 4. It is the same name. We're just using it for multiplication. Symmetric. It's okay. You're adding that, oh, look, I was starting to write it. You're adding that little suffix on the end, saying that you're like describing something as being symmetric. So when you say symmetrical, you're saying it is symmetric. Does that make sense? Sorry? Uh-huh. Number 4.
It doesn't fit on here.
Number 4 cross doesn't fit. Thank you. Number 4 cross doesn't fit. So there's a different name that we can use for this. You had said moving things around, and I said number 4 is going to look like that. What was the name of the property you said when we move things around? Commutative. So let's go ahead and change the symmetric to commutative. Symmetric comes up again. We'll see it again. And it looks a lot like this, which is why it's easy for me to confuse. So we'll change symmetric to commutative. Thank you so much for already starting to fill out your crossword puzzle and double checking to make sure that I'm giving you the correct words.
Was it wrong?
Yes, I can make mistakes. And I will make mistakes. I lean on you, and I really need you guys and depend on you guys to help me make sure that I'm doing it right.
So I was right.
You were right, and I was wrong. How often have you heard a teacher tell you that?
Not that much.
This is your first time. Cherish the moments. Number 11. I've got a thing, and it equals something else. But that thing equals a third other something. That means the first thing I had and the last thing I had are the same. What's the name of that property?
What?
What? So I've got a thing, right? This thing is the same as this thing. that means that, and then this thing is the same as this thing. Which means this thing and this thing are the same. What's the name of that property? Symmetric looks a lot closer to commutative, which is why I confused them. All right, I'm going to start writing it letter by letter.
That's when I,
Starts with an I?
no, it doesn't.
Okay. He's like, she didn't like immediately smile, so I must be.
Transition.
Close.
Translation. Transition.
Transitive. Transitive like mass transit, like the bus system, takes you from one point to another to another. Transitive. Good. Let's do the ones down. Number 1 down. I totally got this wrong on the last time that I did this one. So I'm just going to write out for my answer key what this one is, because I don't know how to explain this. This is the multiplication property of -1. So whenever you multiply anything by -1, the thing stays the same and you just make the thing negative. Multiplication property of -1. 5 down. Okay, this one is symmetric property. Can you see why I confused this symmetric property with what I called symmetric property up here?
Yes.
Look how similar it is. Do you see how closely related they are? Okay, please learn from my mistake. Try to avoid it for yourself. Okay? Okay. 6 down. What do you think this one is? I got A, and I'm adding to it a -A, and it spits out a 0.
Inverse.
Okay, yeah, actually. As I look down, yes, I look at my key, yes. Because it's not identity, because I already used identity. You're so smart. Yeah, whoever said inverse, I think was you.
I did.
You did. Number 7 down. Does it look familiar?
Yes.
Yes. What does it look like in the additions? Just look at the top. It looks like the associative in addition, so this is the associative in multiplication. And number 8. Number 8. We've got a number, we're multiplying it by its reciprocal, and it spits out a 1. Well, you remember the identity property of multiplication? Where we took a thing and we multiplied by 1 and we got itself out? We're getting out the thing that creates the identity. So this is the, I'm just double checking, the inverse. Whenever you have a number that when you apply the operation to it, it spits out the identity number for that operation. In this case with multiplication, I multiplied A with some number and it spat out my identity, the 1. This number, this reciprocal, is the inverse of multiplication. Yes? Slightly confusing. It's cleared up for you in Algebra 2. Alrighty, so you should be able now to do the puzzle. You can fill that out pretty brainlessly whenever you have a moment. Inverse. Let's do the hard stuff. Now there's a difference between expression and equation. Expressions look like these guys, right in here between my fingers. There's no equal sign. Equations look like this. They have equal signs. Expressions you evaluate to figure out what value it would be if I give you some information about the variable. And equations you solve. You take one of the variables in there, you get it all by itself on one side of the equal sign, you put everything else on the other side, and you call it solved. Right now for you, those equations look like variable equals and then a number. I'm going to tell you right now in Algebra 2, and when you hit physics, they're gonna stop looking like that. They're gonna look like letter by itself on one side equals a whole bunch of letters and alphabet soup on the other side. And that's okay, it's still considered solved because you have one variable by itself on one side of the equal sign. Okay? All right, let's do some expressions. All right, example 1, I want to evaluate this thing. And I want to do it if x equals this number and y equals this other number. What do you think I should try to do first?
Write it down.
Substitute. Yeah, you can write it down. Yeah, I'm going to write it down. We're going to substitute. So everywhere I see an x, I'm going to write a 15. And then everywhere I see a y, I'm going to write a negative 7. All right, here I go. All right, feels okay? It's coming back to me? All right, the next thing I'm going to do is I'm going to start collecting like terms. I'm going to start pulling numbers together. I like dealing with the negatives first, so I'm going to bring these two negatives together. Negative 5 plus negative 7, negative 12. Okay, thank you. I'm honestly a little shaky and kind of bad when it comes to doing addition, subtractions, and stuff in my head. So if you're good with that, please help me out and make sure that I'm doing it right. I will mess up at least 40 million times this year. 15 minus 12. Thank you. And there's nothing else to do. It's just a single number, so I'm going to box it and call it done.
So it's been solved.
It's
Done.
been evaluated.
Okay.
Equations get solved, expressions get evaluated. Nicely done. All right, example 2. Who's freaking out because there's a fraction? Yeah, me too. With an expression, there's nothing you can do about the fact there's a fraction. You're just going to have to deal with it. In an equation, though, we can get rid of them. So please make sure that I do one of the ones that has a fraction in there so you can see how we get rid of fractions in an equation, because I agree with you, fractions are annoying. Let's handle the fractions here. I'm going to substitute just like I did previously. Bless you. You're welcome. I have an N, and I have a P. I totally messed up the coloring on that. Okay. 2, and then 2k means 2 times whatever the value of k is. So I'm going to put parentheses to remind myself that I need to multiply. Then I'm going to write whatever the value I was given for k is, plus the value for n. And then the next thing I see is my fraction bar. I see that I have to write the value for p, and then I need to write minus 3. I'm going to put a squiggly bar under the fractions so that you can see I'm done with the fraction. I'm ready for my next step. Okay? All right. I'm going to now use my order of operations by PEMDAS to kind of evaluate and start sticking numbers together. 2 times negative 2 is negative 4. Plus negative is going to be subtraction. And then 5 minus 3 is 2. I'm out of room, so I'm going to come back. The answer is 4?
Negative 4.
Negative 4. Yeah, I agree, because negative 4 minus 4 is negative 8. And negative 8 divided by 2 is, negative 4. You even said negative 4, and I still wrote it as a positive. Easy enough? Okay. All right, looking at example 3, the next one. I see something weird. Do y'all remember what these things meant? Yeah, you definitely want to do them first. There's some sort of grouping symbol like parentheses. Do you remember the name of them?
Bars.
Bars?
Try something. What does it start with?
An A.
I remember, but I didn't. Absolute.
Absolute value. What does absolute value mean?
Like that.
The current value.
Okay, I like where you're going to current value. I heard the opposite. Absolute value means the distance from 0.
Oh,
You were about to say that. It's the distance from 0. That's a cursive Z. That's why it kind of looks like a 3. It's a cursive Z. Distance from 0. Okay, so we're going to play a little game. So,
I mean,
Julian is 0, okay, and then we're going to count this way. 1, 2, and then we're going to count this way. -1, -2, -3, okay? Yes, all right, so -2, stand up. How far away is, thank you, how far away is -2 from Julian 0?
2.
He's 2 desks. So if I were evaluating the absolute value of -2, I would write just 2. Thank you very much, -2. Now, will +1 stand up? That's you, man. All right, there's +1. How far away is 1 from 0?
1.
He's 1 desk away. Thank you. You can sit. And so the absolute value of 1 is 1. It's this line right here that I think caused the answer that was somewhere in this section of the room earlier saying that absolute value means the opposite. Because it looks like you're taking the negative and just turning it into a positive. Okay? You're not. You're counting physically how far away it is from someplace. 0 to be specific. Okay? All right. So, and then like he said, we're going to do the stuff inside of them first before we actually evaluate. So let's get to substituting. I'm going to go ahead and start color coding here so it's easy for me to see what values are what and where they're supposed to go. If you are ahead of me, please feel free to continue staying ahead of me. All right, so 3, the absolute value of whatever A was, minus whatever B was, close the absolute value, plus 2 times the absolute value of whatever C is, minus 5, close my absolute value. Okay. Notice we've got a double negative happening, right? We've got minus and negative. When I have minus and negative, what happens? It becomes a double positive. So anytime you have that set up, you can do that. And then I'm going to do my normal evaluations, yes. It's going to be a positive 2. Very good. And this is a -2. All right, so this is 3 times whatever the absolute value of 2 is, which is 2. And then this is 2 times the absolute value of whatever -2 is. 2. 3 times 2 is?
6.
And 2 times 2 is?
4.
And 6 times 4 is?
11.
What?
Oh, well,
Guilty. Done that. Easy?
yes.
All right, let's do some solving. Gonna take a moment. I'm gonna scribble over here off to the side for a second. Our good friend. Yep. When we are evaluating an expression, which is what we just finished doing, you take them in this order, yes? It's like getting dressed in the morning. When you're getting dressed and you're going to wear tennis shoes, you put your socks on and then you put your shoes on. Because it would be weird if you did it the other direction. Right? Put your tennis shoes on and then put your socks on.
Unless you want to keep your shoes clean.
Well, you know, there's that too. But if you want to wear your socks and shoes like a normal person, you put socks on first and then you put tennis shoes on, yeah? When you're doing the solving thing, it's getting home at the end of the day and taking your shoes off. If you've put on your socks and then your shoes, you're not going to take your socks off first. You're not wrong. You're not wrong. You can take your socks off with your shoes. But if you had to do it in 2 different moves, you would take your shoe off first and then you take your sock off. Yes? All right. So evaluating PEMDAS as normal, solving, you got to go PEMDAS but backwards. Okay? Okay. Let's look at number 2 first. Hi. Back with me. Thank you. Let's look at example number 2. Well, question? No? Okay. Let's look at example number 2 first. Okay, when I look at this, what do you want to do first?
Distribute.
Okay, we can totally distribute. If it looks like distribution is going to make big numbers, like let's say this in here was like a 54. 3 times 54 is, I don't know, I'd have to get a calculator, it's a big number, I don't know.
160.
Snap, you go, 160
No,
something maybe. See, some people can do this, I can't, it's not gonna happen.
162.
Right? I'd have a calculator to do that, because I can't do that in my head. But it's hard, it's a big number. And so you could think of this as 3 times something and undo the multiplication without doing the distribution. You're allowed to do that.
Without?
You are allowed to. You can. But if I were to divide by 3, I'd end up having to divide this side by 3. And 13 divided by 3 is some decimal or fraction, and I don't want fractions in my equation, so I'm not going to do it. So I'm going to follow what was suggested by, don't remember where in the room suggested it, but let's do the distribution. The numbers are, yeah, oh, yeah, thank you. I'm going to follow your suggestion. I'm going to distribute. The numbers don't get too big, and if I tried to divide, fractions. Okay, distribution. Here I go. I need a different colored pen. So I'm going to distribute here and here. Everyone feeling okay with this so far? Yes? All right. I need to get rid of the 15. What do I do? It's inverse, so I'm going to add. Nicely done. All right. That's going to get rid of this, and I'm going to have 3x equals 28. Thank you. You saw me having to do it the long way. And then I'm going to get rid of the multiplication by doing what?
Divide.
Beautiful. It's inverse. Divide both sides by 3. 28 divided by 3 is
So if you can't,
yeah, I'd have to put it into a decimal, so I'm not going to. So we're going to leave our answer as a fraction, just like that. If you can reduce the fraction to simplest terms, do so. You know, if your fraction is like 2/4, change it into 1/2. Okay? All right. Does anyone need to see example number 1 when we've got variables on either side? I heard a yes from somewhere, so we'll go ahead and do it real quick. If you don't need this and you want to skip down to the bottom of the page and start working, you can, and you can just tune me out for now. All right, for those who wanted this, I have a variable on both sides of the equation. What I need to do is I need to get the variable so it's on one side of the equation. So I'm going to look at both of these variables, and I'm going to ask myself, where is the variable with the biggest coefficient, the biggest number in front? That's this one. So I want the y's, the variables, to be on this side. Because when I do that, it keeps the variable positive, and I don't have to go through the extra step of multiplying or dividing through by a negative to clear out the negative. Okay? So that's going to help me keep things nice and tidy. Just going to do the inverse there. And so I'm left with that. And now this feels like normal. Yes? And everything there was exactly like what we did on the other example. Questions on anything I did? Okay, good. I do want to do one more example for you. Let's look at your choice of 13, 14, or 15.
15.
I heard 14 or 15?
15.
15. Okay, so here I'm giving a few people some time to finish copying, a few more seconds. I'm going to switch down to number 15. Okay. Can I get that copy for you a little bit later? All right, number 15, fraction. But it's an equation. See the equal sign? This means we can get rid of it. To get rid of fractions in an equation, multiply by the denominator. Which one's the denominator?
13.
13, the one on the bottom. Okay, I'm going to multiply this by 13. I'm going to multiply this by 13. I'm going to multiply this by... Multiply everything in the equation by the denominator. Okay, that's going to cancel it here. 13 times 2 is 26.
So it's not negative 13?
It's not, okay, you could do it by negative 13. And that would get rid of this negative. Yeah, you could do that. I decided not to. Because I didn't think about it. But yeah, you could if you wanted to. 39. All right, gonna add 26 to both sides. Negative t equals 65? Okay, and then I need to get rid of the negative, so I'm gonna divide everything by -1. Or multiply by -1, it does the same thing. T's all by itself. Everything else is on the other side. I'm done. Easy enough?
I know how you got that.
All right, thank you very much.